Okay, so this is just a mini lesson over stuff that we've already learned. It's prime factorization and greatest common factor. So after you fill in the blank, you can go ahead and try the examples on the bottom because you probably already know how to do them. But if not, then you can just watch because I'm going to go over every single one of them. But go ahead and fill in the blanks on the top. For prime factorization, that's when you have to make a factor tree and then you circle all of the prime numbers and then you write it out using exponents. So that's what steps 1 through 3 are saying. And then for greatest common factor, that's where you have to find the biggest number that two numbers have in common. And you can use two different methods. You can either make factor trees or you can make a list. You can go back and pause it if you weren't done copying all that down. But I'm going to work out the bottom examples on this page. So we have the number 54. And this is for factor trees. So the idea is that you need to find two numbers that you can multiply together to get 54. There's a couple ways you could do it, but I know that 9 times 6 is 54. So I start there, and neither one of these is prime, meaning that neither one of these has only two factors. So 9, two numbers I can multiply to get 9 are 3 and 3. And then two numbers you can multiply to get 6 are 3 and 2. And then you would circle all of these because they are prime. Okay, so I have 1, 2. So 2 times, and then I've got 1, 2, 3 threes. So you could write it out as 3 times 3 times 3, or you could just do 3 to the third. Try to do the prime factorization for 63 on your own. And we'll come back to that one at the end. So go ahead and pause the video and try to work out the factor tree for number 63. Okay, so there's a couple ways you could do it, but I saw that 9 times 7, and then 7's prime, so we don't need to branch off of that one anymore. Go ahead and circle it. And then for 9, you can multiply 3 times 3. So now I have all prime numbers, and so my final answer, you should have gotten 3 squared. Oh, that does not look like a 2. Let's try that again. 3 squared times 7. Okay, if you did not get that, you should raise your hand and ask a question. But moving on, so we're now finding greatest common factor. So one method you could use is to make a list. So our numbers are 16 and 48. So starting here at the factors of 16, well, let's see. We've got 1. Oops. We have 2. 2 goes into it. 3 does not. 4. 5, no. 6, no. 7. 8. 8 goes into 16. And then 16 goes into 16. Okay, 48, this one's probably going to have a lot. So we have 1, 2, does 3 go into 48? Yes. 4 does. 5, no. 6, yes. 7 does not. I'm going to have to start down here. 8, yes. 9, no. 10, no. 11, no. 12, 13, no. 14, no. 15, no. And then 16. So making the list sometimes takes a little bit longer, but you should be able to stop here and see that they both have a 16 in common. So your greatest common factor is 16. And if you think about it, 16 goes into 16 one time, and 16 will go into 48 three times. Let's see. The next one, we're going to have to make two-factor trees, so I'm going to have to make some space. Okay. So we've got the numbers 45 and 72. So we're going to have to make two-factor trees, so starting with 45, 9 times 5 is 45. The 5 is prime, so you're done. 9 is not, so you could do 3 times 3. And then you've got, so for 45, you have 3 times 3 times 5. And then 72, for 72, you can multiply 9 times 8. Neither one of those is prime. So you have 3 times 3 and then you've got 4 times 2. And then 4 can break down to 2 and 2. So these would all be circled. I'm just not going to circle them because it gets really hard and sloppy. So we have 3, 2, 2, and 2. So it would be 2 times 2, and then 3 times 3. Oops, I forgot a 2. So I'm going to back up and put that in there. Okay, so right now we're looking at this. Okay, so this 3 times 3 times 5 is the prime factorization for 45, and then 2 times 2 times 2 times 3 times 3 is 72. So now we have to circle what they have in common. Well, there's a set of 3's right here, and then there's a set of 3's right here, which means 3 times 3, our greatest common factor is 9.